Let's start with the session. So good morning, everybody. So today's session will be on how do we configure BSWM in AutoSAR. Yeah, so today's agenda will be like a short welcome to you all, and then we will discuss on do's and don'ts for the first time comers of these sessions. And then we'll continue with our today's agenda, how do we configure the basic software mode manager BSWM in AutoSAR projects. So starting with the short introduction. So in this session, we'll have beginners, proficient people, experts. So it's a combination of people. So it's so all of us, for the sake of session, we will consider ourselves all of us as beginners, so that we can try to learn. So basically, the expectations for the participants can be. Yeah, sorry. Is my audio clear or some issues?
Yeah, it's
No, it's
clear.
clear.
Yeah, fine. Thank you. So just let me know if in case you are having any audio issues. Okay. So for the expectation for the participants from the session can be, we will try to understand the different configurations involved in the BSWM configuration, and then followed by the regular use cases of how the BSWM will be used in different automotive projects. We'll have some examples considering the time constraints, and then we will have some tips and tricks wherever it is possible. So wherever we have some tips and tricks from our experiences in the automotive projects, we'll also discussing on those things. So that can be the expectation from the participants from this session. So coming to the most important point that is the do's and don'ts of the session. So for the first time visiting participants, so we have some do's and don'ts for this session which we strictly follow. So coming to the do's part, so please do consider all the participants in the session as beginners in the AutoSAR. And then during the session, we can ask any basic questions. There is no question about, okay, why this question is being asked. So, and we believe learning will be complete only when we're able to accept very basic questions and discuss on them. If we know the answers, well and good. And if we don't know the answers, yeah, we will park the questions for the next coming sessions, and where we'll try to understand more deeper into that particular area, and then we will have our next sessions planned. So coming to the next point, be proud to accept when our understanding is wrong, and be open enough to learn from others' experiences. So yeah, generally during the discussion, there might be different types of answers coming in, and then when we understand that, okay, the other person has a better understanding, so let us try to learn from his experience, and yeah, without hesitating. And then whenever our understanding is wrong, be proud to accept that it is wrong, and then yeah, learn from others' experiences. Coming to the don'ts part, please do not judge any participant based on their question and answers. So sometimes the questions can be very basic, and so please do not judge. So because here we are all considering everyone as a beginner, so any question might come up in the session. And please do not mind about what other participants will think. Whenever you want to shoot a question, just shoot out the question. We will try to discuss on that. And throughout the session, we will not have any exaggerations. So, and we are not representing any company here, or not we are branding anything. So we'll try to stick to the very basics of the topic, and we'll speak whatever that really happens inside a project. So we'll not try to exaggerate anything. And the last and most important thing, please do not mention the name of your organization or the OEM with whom you are working when you are referring to any real-time questions, because there will be some privacy issues, or you have some every company will have this policy. So we should not reveal the details of our project, or whatever is the OEM we are working, or whatever the stacks we are working. So let us not try to bring in any of the stack names, or your OEM names, or project names, or company names here. I will also be following the same thing from my side. So we'll just talk on to the topic. Okay, so we will start with the topic. So the today's agenda, that is the BSWM. So what is this BSWM? So BSWM is like a mode management framework. Okay, so what do we mean by mode management? So in our ECU, we will have different modes with respect to the ECU modes, with respect to the vehicle modes. with respect to the different ECU states. Okay, so when I talk about ECU states, I'm talking about wake up, start, then run mode, post run mode, and then again shutdown mode, and all those things. Okay, so how do we handle these different modes? So the BSWM is the feature in the AUTOSAR, so which enables handling of these modes in an ordered manner. So that is what is the base BSWM is all about. Okay, it's a very simple module, but it has the capability to do a lot of things. Or it enables the AUTOSAR users to do a lot of checks, and then based on the certain inputs, we'll have the different mode related handling inside the ECU. So that is what is all about. So let's see. So when we talk about BSWM, so when we go further into the next slides, we'll get more and more better understanding. But to start with, there are two main operations for a BSWM. So these two main operations, as you can see here, first thing is the mode arbitration, and the second thing is the mode control. So let's see what is this each is about. Okay, so if we start with the mode arbitration, the mode arbitration part initiates mode switches resulting from rule-based arbitration of mode requests and mode indications received from software components or other BSW modules. So before we start with this, let me explain in a little bit. So basically what will happen, so on our applications, for example, whatever the software components or the features in your application layer, okay, they will need to switch from one mode to another mode based on the requirement, or they might want to understand what is the current mode of the vehicle to accordingly, that so that they can behave. Okay, so every module or every application might have different requirements based on the different stages of your vehicle. So when you initially wake up, there might be some different requirements for your application, and when you start entering into a run mode of your OS, so you might have to perform certain actions. And again, when you are leaving the run mode and then coming into the post run and then the sleep and off modes, so again you might have to perform different actions. So for all these things, you will definitely need the information of these vehicle modes to the applications. And similarly, the BSW modules also, first thing is they have to provide services to the application layer for handling different modes or giving the information about different modes. So all these things can be handled by using the BSWM module, the BSW mode manager module, in an efficient manner. So if you see here in this case, either the person who requests is an application, and the person who caters the service is a BSW module, or the BSW module gives some information and then the application will receive this information. But this happens via the BSWM module. So that's what is the basic concept of how BSWM will work. So BSWM is a set of rules basically. So these rules are executed based on the inputs either from the application module or from the BSW module, and the output will be like it is given. It either gives an mode indication to the other modules, or when you request for a mode switch from one mode to other mode, the mode switch will happen. That will be taken care by the BSW module. So these are the different possible mode related functionalities that can happen in our ECU. So how we will see now how this BSWM module will support these kind of implementations in our ECU projects. So first thing, like we discussed, now the mode arbitration. So here when we talk about the mode arbitration, the input will be the mode request or mode indication from the software component or a BSW module. So software components, generally they will request the BSW modules to switch from one mode to another mode. Okay, I can tell you an example. For example, when you talk about LIN communication, so when you want to switch from one LIN schedule to a different LIN schedule, so this LIN scheduling request from the application will be given to the LIN module, LIN SM, okay, with the help of BSWM. So there will be a mode request port inside our application, and this mode request port is connected to BSWM. They will be providing the mode request ports. So are the mode indication ports. So there we will have the mode request coming, and then that request will be verified by BSWM using some rules checks, and then once it is passed, it will give the indication to the LIN schedule manager to switch to the respective LIN schedule. So this is one typical example. Similarly, the BSW module has some mode change, and then this gives a mode indication here. So as you can see, it can be a mode request coming from the software component or a mode indication coming from the BSW module. So these two, either of these two can be the input for this rule check, and the output will be the mode switch to a different mode. So whenever there is a mode switch request coming from software component, it will be a mode switch, or whenever there is a mode change indication, that will go to the application. So this is the two possibilities that we consider as a part of the mode arbitration. The other next part, important part, is the mode control. So what do we mean by mode control? So mode control performs the mode switches by execution of action lists. So we will have some action lists. We will see in the next slides what are these action lists. So what do they do? So here in this case, there is a person requesting and the person is actually responding. But whereas in this case, it is a cyclic check. So whenever we are executing the BsWM main function, so we will have some action list checks will be done, and then based on some logical expressions, whenever this particular conditions are achieved, obviously, then we will have the mode switch happening. So these mode switches are based on certain input conditions. The condition check, whenever the condition checks are passed, then we will be switching to the respective modes. So here it is like on request basis or based on some event basis. Okay, so these are the two ways the BsWM functionalities will be implemented. So we'll see what generally will happen. So when we talk about BsWM rules, so these are, as you can see here, we have mode, condition, logical expression, action list, and rules. So these are the main things that we'll be configuring when we are configuring the BsWM module. So simply, if you understand these 5 terms, so then you're familiar with the BsWM configuration. You're good to go with the BsWM configuration. We will see one by one what and all is about. So the first thing is the mode condition. Mode condition is nothing but a condition check to compare if the mode request or mode indication from a software component or a BSW module is equal or not equal to a configured mode. So obviously, like I told, so the whole of BsWM implementation will be done based on a condition check, and then when the condition check is passed, there will be one action. If it is failed, there will be different action. So it's like a Boolean algorithm. If you get either true or false for the condition check or the mode condition check, and then the condition passes, then we will have certain next operations to do. So we will see all of this. So mode condition is that, here the mode condition talks about the different modes that we will configure for the BsWM to compare the mode conditions. So it can be an application mode, it can be a BSW related module related mode. So all these mode conditions will be first configured for the BSW to enable to perform the checks, whether the mode requested mode and the achieved mode are same or not, or we want to switch from one mode to another mode. So basically, we will need the mode related information to be given to the BsWM first, and that will be done as a part of the mode condition configurations. The next comes is the logical expression. Now we have the BsWM mode condition related information available to BsWM. Let's say, for the sake of easiness, we can say like vehicle mode. So we will have different vehicle modes, the ECU modes, like the wake up and then start and then initialization and then run mode and then post run mode and then let's say what we call shutdown mode and then finally to the off mode. So let's say these are all the different modes that we want the BsWM to handle. Then first we have to configure the mode conditions so that the BSW can perform the checks against these mode conditions. So now we have the mode conditions available. Next we'll enter into the step of logical expression. Logical expression is nothing but we will be checking the conditions using logical operators like AND or XOR or not or NAND. So basically we will have some checks and we can actually combine more than one check, okay, or let's say two check operations using the operators, the logical operators like AND and. So when both the conditions are met, then we perform this action, or either of these conditions are met, so you can perform this action. So these the logical expressions are nothing but the expression checks using the logical operators. So now we have the mode conditions, we have the checks. So now that we have, based on the mode condition, a logical expression check is done, and it can be also be a combination of multiple checks. And once this is done, then we have a result. Either it is the condition check is passed or the condition check is failed. So in either of these cases, then we have to perform an action. So this action is nothing but the performing an action based on the result of logical expression. But the important point that we should understand here is the actions, whatever we say that, okay, based on these mode conditions. So whatever the actions that we perform, these are all predefined and it is available from your stack supplier. Okay, so whatever the BSWM stack you receive from your stack supplier, the stack will contain some predefined actions. So we can actually perform only these predefined actions. So why they are predefined? This is the predefined is done in the predefining of these actions is done in AUTOSAR, just to ensure that, okay, it is not too much generalized. We are having stability in the BSWM module. So to have the stability in and the proper implementation, the BSWM actions are all predefined. We cannot actually add any new actions, but there is one action which will enable us to perform whatever we want to do. That is actually there is an action called user callouts. So these user callouts will be able to help us. So whenever we want to perform an action, so we can have a user callout function defined, and inside the user callout function, you can perform whatever you want. So, but the standardization of these actions are done using the action called user callouts. So now we have understood there is an action. So we have initially configured a mode condition, and then using these mode conditions, we are performing a logical expression check. And whenever the logical expression check is either passed or failed, then we have an action to perform. And this action, again, it is actually, for example, a single result can have multiple actions to be performed. In that case, then we have this action list in place. So this action list is nothing but a group of actions that can be performed together whenever a logical expression check is passed or failed. So it's not that we see, because otherwise what will happen, the number of actions, the list of actions will keep on increasing. So just to bring them into an order, or to optimize these actions, so they have introduced something called as action list. So basically what will happen, so once we have a logical check is passed or failed, so if you have list of actions to be performed, then we will be listing all of them in something called as action list. The next comes into picture is the rule. So a rule is typically a logical expression that is composed of a set of mode request conditions. The rules are evaluated when the input mode requests and mode indications are changed, or during the execution of BSW main function. The result of the evaluation, true or false, is used to decide about execution of the corresponding mode control action list. So basically, if you look at the rule definition, it is covering everything here, as you can see. So basically, a rule, what will happen, the logical expression, whatever we have talked about here, that will be, which is containing the mode condition, different set of mode request conditions. So the logical expression will be evaluated, and then when the input mode or the request, the input mode request is coming, or a mode indication is changing from a BSW module. So in either of these two cases, like we have discussed, it can go in the arbitration mode, or it can be part of the execution of the BSW main function. So whenever there is a request coming, the action can be performed, or during the cyclic checking of the BSW main function, the BSW inside the cyclic checking of the BSW main function, we will be checking all the rules conditions. And whenever some rules passes, or the logical expression, basically when we say about checking a rule, it is about checking the logical expression related condition checks. So whenever either of these two cases, either it happens on event basis or in the cyclic basis, so when we have some results for these logical expressions, basically the result can be either a true, that means the expression check is true, or expression check got failed, or it is false. So in either of these cases, we will have certain actions that will be mentioned as a part of true action list. So so we'll have a list of action lists. So we'll have action list which has to be performed when the condition is met true. And we'll also have some action list. Again, it is optional. It is not a must and should rule that we have to have a false related action list also. But there is an option provided. So whenever there is a true result, perform this action list. Whenever there is a false result, perform this action list. So basically, this is what is mainly that we should understand when we talk about BSWM configuration. So here, if you understand these things, so basically you are done with the BSWM configuration. Simple. But now we will, like I told, BSWM has a lot many number of operations that it can perform, or it will be supporting the users to perform. So let's see, let's go deeper into all of these things. So first we will take with an example use case. So we have talked about mode condition, logical expression, action list, and BSWM rule. So now let us take with an daily use case example that we'll be using in our project. So on the use case, whatever I have taken is the ECU sleep implementation based on the communication channel state. So now my intention, what is my requirement is whenever the communication channels are all are setting to no communication, I want my ECU to go to sleep mode. So this is the my requirement, and I want to achieve this using the configuration of a BsWM rule. And obviously when I say about BsWM rule, it includes configuration of actions, action list, logical expressions, and the mode conditions. We will see for this what will be our mode conditions, what are the configurations that we will do. So the first thing to start with is the mode condition. So mode condition, what we want to check here, we want to check the CAN SM channel state. So the CAN SM channel states, either it can have a mode of full communication, or it can have a mode of no communication. So in the mode conditions, we will give the information about the CAN SM channel states. Okay, to this information we are giving to BsWM. And then we have to configure a logical expression. My logical expression, what I want to configure is check if the CAN SM channel states for all communication channels in the ECU using AND operator. So I want to check the CAN SM channel states, but is it sufficient to check the CAN SM channel state for one channel? No, I might be having, let's say, 3 or 4 communication channels. Okay, and out of which, let's say 2 CAN channels are there and 2 LIN channels are there. So when I have to check the channel state for all the communication modules, so along with CAN SM, I might be supposed to take the communication status from the LIN SM also. In that case, I will be giving the information about the CAN SM channel state and the LIN SM channel state as my mode conditions. And then in the logical expression, I will be comparing the CAN SM channel state to whether it is equal to no communication for all the CAN channels. And similarly, from the information I received from LIN SM, so I will be checking for the LIN SM channel state for all the LIN communication channels. So now how this is performed? This is performed using the logical AND operator. So my condition check will be CAN SM channel state 1 equal to no communication, and CAN SM channel state 2 is equal to no communication, and LIN SM channel state 1 equal to no communication, and again LIN SM channel state 2 is equal to no communication. So this will be the logical expression I will be configuring. So once this is done, so now we have to configure the action. So what is the action to be performed? So what we have done here is we have given input conditions. What are the input mode conditions? And then we have also given a condition check, that is the logical expression. And now we have to perform action. So the action one I have to have is trigger a callback function in software components to indicate the entering into ECU sleep mode. So now I want my ECU to enter into sleep mode because there is no communication happening. There is no vehicle communication happening. I want my ECU enter into sleep mode to optimize my battery usage or the energy usage inside my vehicle. So before going to sleep mode, there should be an indication to all of my application modules, maybe because my application modules might want to perform some actions, some critical actions before going into sleep mode. So the first action that I want to perform before executing the action is that I want to give an indication using a callout function to all my application modules. Okay, that the ECU is now going into the sleep mode. Then action 2, once this is completed, the action 2 is that request the ECM state switch to sleep mode. So I will have to basically the ECU modes are handled by the ECM module. So there I am going to request the ECM module to start entering into the sleep mode. So now we have configured 2 actions. So now the action list will have the combination of action 1 and 2 in the same order. So it is also quite important that we perform these actions in the same order. Otherwise, we won't be achieving the required functionality. So what will happen? The action list will have set of actions, means action 1 and 2 in the same order. So now the rule will be executed. Basically, in the BsWM cyclic functions or BsWM, the mode indications or mode request things, the rules will be checked for the logical expression is either true or logical expression is either false. So in case whenever now in this condition, I will check for the CAN SM and LIN SM channel states. So when all the channels are in the no communication mode, then my logical expression result will be true. And then I will need to execute the action list, that is action 1 and 2. And when the check result is false, here I have considered a use case of I don't do anything, I'll continue in the same mode because everything is in the communication is running. So, but in other cases, if we want to perform some actions whenever the condition check is false, like it is still in the full communication, then I can configure something like, okay, enable the run request mode, continuously send the run request mode to my ECU, something like that. So this is one typical use case example. Okay, so now how this code is implemented. For example, we have now talked about how do we configure these things. But if you look at the typical, the pseudo code, okay, what will happen inside the BSWM is the arbitration. So now what will happen? So this you can see the same code that will be generated whenever you configure BSWM. The BSWM rules executions or the arbitration will be happening in the same thing. So if my mode request port is equal to mode A, so this is the mode which we have already given information in the mode conditions, and common initiate reset is equal to ESET. So here we are checking for a common state. Okay, so there is, whenever there is this initiate reset is set, and then the mode request port is equal to mode U, then execute the true action list, else execute the false action list. So in this case, this is the rule and this is the logical expression, and you can see it is an AND operator here. So when both these conditions are met, the logical expression is true, execute the true action list, and whenever it is false, execute the false action list. This will be very simple. The BSWM execution is very simple. It is basically a true false condition check, a binary condition check. So what is the advantage of such code implementation is there is no performance related overloads because of BSWM module. So that is the expectation, that all the executions inside a BSWM is very simple and as simple as whatever you are seeing on the screen. So this screenshot, this is, you can see it from our the specification from the AUTOSAR.org for the basic software mode manager module. So even if you look into your generated codes inside your projects, you will see the same kind of implementation for each BSWM rule or arbitration rule. Okay, so now we will see some critical things for each of these topics. So action list execution method. So when I spoke about action list execution method, there are two things that we have to consider here. So execution of action list. So now we have the rule check happening. The logical expression is checked, and based on a true condition, now we have to perform an action list execution. So the action list execution happens in two ways. One thing is the BSWM trigger, and the other thing is the BSWM condition. So trigger means action list will be executed only when the result of the rule evaluation changes from its previous state. So it's kind of a deferred way of implementation. So where we have the previous condition and the current condition is different, then only it will be like, it is not a continuous triggering of or continuous execution of the actions. So it is based on only whenever there is a condition changed, okay, or change in the modes. In such cases, this we will be performing this action. And condition is nothing but action list will be executed every time the rule is evaluated. So every time when the rule is evaluated, so either you have a true or you have a false condition. So at least for every cycle you have some action list execution. So based on your respective use cases and the intended behavior, we have to carefully select these options. Either you want the BSWM action list execution to be done on the trigger mode or on a condition based mode. Okay, so like I mentioned, on condition based mode, every time your evaluation is performed, your evaluation will have either a true or false result. So in any of these cases, you have something to perform. So in some cases, for example, the typical use cases like where you want to give continuously the run request to your ECU. So you have some condition, you are configuring some rule. In that case, either it is true or false, you have to give some indication to your ECU about either we have to take up the run request, or we have to release the run request. So always cyclically you have to give some indication to the other module. In that case, you will be going with the condition based thing, or if it is only on need basis or an event basis, so you will go with the triggered kind of implementation. Okay, similarly we have BSWM request processing. So there are different ways of doing this. Let us see. So BSWM request processing configuration parameter is part of. So if you look at the container of this BSWM, so you will see one container called as BSWM mode request port. So we will be looking more into details like what does the configuration of this BSWM mode request port contains. But for now, this BSWM request processing configuration parameter is part of this container. And there are two different types of execution of this mode arbitration based on the value that you configure or the parameter that you configure for this request processing. So the BSWM arbitration, the mode arbitrations will be done accordingly. So for example, whenever there are two different things which are generally supported, that is BSWM immediate and deferred. But if you look at some of the stacks, they also support one more mode called as the forced immediate. So basically in simple terms, when we talk about this mode arbitrations, so when, for example, whenever there is a mode indication coming from the BSWM module, or there is a mode request coming from the application module, so how this is executed, that is what is this BSW request processing. So there is a request coming from the application, or an indication request coming from the BSW module, that the indication need to be given to all the listeners. So in such cases, how frequently or how do you process this? So when we configure immediate, so what will happen, the mode arbitration execution is performed immediately after the mode arbitration. So when the request comes, it is kind of an interrupt. Okay, when the request comes, so the arbitration will be done. That means the verification of the logical expression will be done immediately, and the respective action list will be executed immediately. Here, for example, in case of, for example, if you are getting more than one such immediate request coming into picture, we will have the queuing mechanism. So all the requests which are coming with this immediate as the request processing mode, they will be queued and then they will be executed one after the other. Okay, whereas in the case of, if you configure it as BSWM deferred, what will happen? Whenever your condition is the mode request comes, it will set a flag, and then in the next subsequent BSWM main function processing, your arbitration check will be done, and then based on the flag status, the last received flag status, it will be executed in the next main function processing. So whereas in the case of immediate, whenever the request comes or the indication comes, it will be executed. The rules arbitration will be done immediately. Like I mentioned, some of the stack supports this forced immediate mode here. What do we mean by forced immediate is, what is the difference between the immediate and the forced immediate? Immediate and forced immediate, what is the difference is, in the forced immediate, there is no queuing mechanism. At any cost, you have to perform that action. Okay, so it will be done immediately after mode request indication. This will interrupt any ongoing immediate or deferred arbitration. So let us assume at that time there is an immediate arbitration happening. So what will happen? This will be interrupted, and then this will be put into queue, and then immediately the forced immediate condition will be executed, and then it will again continue with the immediate, and then it will continue with the BSWM deferred action. So you can ask me a question that, okay, what happens when there is two simultaneous forced immediate things comes into picture? Generally, that is not the recommended way of doing it. This forced immediate should not be used just like that for each and every BSWM rule. So it is again the architecture, the person who is architecturing this BSWM, they will have to take enough what we call, generally it is recommended to have only for very high critical things, and which will not happen simultaneously. So in such cases only we will be going for this forced immediate. And also, like I mentioned, it may not be supported by each and every stack supplier, but stack supplier, 2 or 3 major stack suppliers, they support this forced immediate mode. But otherwise, the general basic things that you will get from every stack is, as per the AUTOSAR standards, you will be getting this immediate and the deferred way of the request processing for a BSWM arbitrations. Okay. And let's see how whatever we have discussed now, let us try to now bring it all of them together, and then we will see how this mode arbitration, what do we mean by mode arbitration, and what do we mean by the mode control. So basically the whole of BSWM functionality, it is basically a combination of the arbitration and then the respective mode control. Okay, so now generally what will happen, if you can see from this picture, so there is a mode requesting software component inside above the RTE. So this application module requests the BSW module for switching into a different mode. It can be RTE related mode, or it can be in BSW mode. So once this mode request comes, okay, what they either based on whatever the request processing method we have chosen. Okay, either it is what we call deferred or immediate, or deferred, or forced immediate. So based on that, the arbitration will be executed, and then whenever they based on the when we say about rules checking, it is about the logical expression validation. And once the logical expression is either true or false, based on that, it will be executing the action list, and this action list will have the either it can be switching to a different mode, whereas because we are considering the use case of the mode request coming here, so it will be obviously a mode switch. Okay, this mode switch can either be this given to like a request going to BSW module, or sometimes this can be again coming back, there will be this mode switch can have some indications. Again, this whenever after the BSW module is switched to a different mode, we will also need an acknowledgement. This will be implementing using an indication. So whenever the BSW module switches to a different mode, it will give an indication again back to the application layer. again using the BsWM using an indication port, mode indication port. So there can be another module which will be receiving this mode indication, and based on this mode indication, again it can perform certain actions. So in some cases, there is also a possibility that the same module which is requesting the mode can also be a module which want to get the indication back. So in this case, what we'll get is the local mode handling that is coming from the BsWM to the mode requesting. So this can happen cyclically. So wherever the application module can continuously request for different mode switches, and then again after the BSW module changes this to a new mode, it will give back the indication back to the application module, or sometimes to the same application module, so that it is acknowledged that okay, there is a change in the mode condition. Now I can perform the next action sometimes, or I can perform a different action if it is for a different application module based on the mode set, it can do this. So general typical example use cases like the application want to continuously change. Let's say I can take a typical example of again the lin scheduling request. So after a execution of one schedule, it has to switch to the next schedule. So in this case, what needs to be done? Whenever the request goes from this application module, it goes to the lin schedule manager. And once the lin schedule manager changes, there will be an indication given back to this. So this will be like an acknowledgement. Okay, I have sent a request and now the action is performed. So now this acknowledgement comes back. So now it can actually start requesting for the next schedule table. Okay, so this can be one typical example. So this is the general sequence, okay, that will be scattered by a BSW module to the applications between the application modules and the BSW modules. So mode arbitration, like we understood from here, it is simple rule-based evaluation. Evaluation is done using the logical expression check results. And when based on these evaluations, we'll have the execution of action lists. Okay, so and if you look at the action list, it is nothing but lists of actions. And like I mentioned, these actions are predefined. And generally there will be BSW service function calls or user callout functions or calls to nested rules. Again, you can have a rule inside the rule check, okay, or a list of action lists. So basically an action can be configured to call a different action, because this is to reduce or optimize the number of actions and to also ensure the hierarchy, like in a sequence, this is the first action to be performed, and then an action can again call another different action, and then that action will be executed, and again the control will come back to the previous action and it will continue in the list. So in such, that is called as the cascaded. So this cascaded action list, there is a limit on how many number of cascaded action lists that you can configure in AUTOSAR project, that is limited to 7. Okay, there are different reasons behind this why it is set to 7. This is for enabling some testing conditions. So AUTOSAR has limited this number of nested or the cascaded action list to up to 7. So now we understood basically the whole BSWM functionality is done using this mode arbitration and the mode control. So now it comes the next very important thing. So now we understood how BSWM works, giving the input conditions, creating logical expressions using these conditions, and then when the logical expression false or fails, we have some actions and action list. And all these verification is done as a part of the rule arbitration, and that will be performed either on an event based on the mode request or indication coming, or on cyclic check in the BSW main function. Now the next important thing that we should know how efficiently we can make use of the BSW modules. Like I told you, BSWM acts as he's the guy who handles the modes carefully and in an ordered manner, and then it acts like the bridge or communication for the mode handling between the application modules and the BSW modules. And here we can understand from here how this BSWM can provide different services. Okay, and what are the different services provided by BSW module from various BSW modules. We'll see one by one, and we'll try to cover up on a high level. Okay, what are all the major services that will be typically used in any project? So first, let's start with the RTE. So for the RTE, how BSWM interacts with RTE. BSWM receives mode requests from the software components. That's what we have seen. And mode switch notifications are also propagated to the software components via the RTE. So requests come from the application layer to the BSW layer and using RTE. And again, whenever there is once the mode is achieved, there is a notification we want to send, indication you want to send to the upper layer modules in the application layer. This also happens by RTE. So BsWM interacts with RTE for these two operations, for taking the request from applications and giving it to BsWM, or taking the node notifications or mode indications from the BsWM and giving it to the application modules. Next comes is the ECM. So using ECM, what are the different BsWM actions we can perform? So when ECM will indicate the current ECU state to the BsWM. So whenever there is a change in the ECM mode, an indication will be given to BsWM, and this mode can trigger an action to an application module. Okay, but that whenever there is a ECU mode changes will happen, then this will give a indication to the application module. Accordingly, the application can be configured to perform a different action. Next thing is the COMM. Same is like for the communication mode manager. So mode switch indication originating from the COMM go through the BsWM for further propagation to the software components. The BsWM can request communication modes at the COMM by means of COMM users. So there are two things. Whenever there is communication mode is changing, let's say from full communication to no communication to silent communication, or either any of these sequences, whenever this communication mode changes, there can be an indication that can be given to application module saying that, okay, now I am going to shut down my communication, or the communication is no more available. You please start processing, or you please do not consider the data that you receive as a valid data. So this can be one typical use case using the COMM. Similarly, we can also, for example, when we have a communication manager related application. Yes, please. Hello.
Sorry for that.
It's okay. Yeah. So for the communication manager, when we want to configure an application to be handling this communication management, like having the possibility to request for no communication, having the possibility to request for full communication, in such cases we can configure COMM users, and then BsWM will provide service ports to the application layer to request for this communication full mode, or communication no communication, or full communication modes. So this can be achieved using the COMM user configuration. So when it also BsWM can trigger transmission of an IPDU. So it can also so whenever we put this, we will be able to okay, we are talking about the communication manager. Next go to the COM. So the handling of IPDU. So what are the different services that COM provides? The handling of IPDU groups in COM is performed by the BsWM. So the IPDU group starting or stopping of the IPDU group transmission is generally done by using the BsWM. As a part of IPDU group start or stop, it is possible to have the included signal values reset to their corresponding initial values. BsWM handles the enabling and disabling of deadline monitoring of signals in COM. So we can perform deadline monitoring, we can perform the start and stop of these PDU groups. We can also perform the resetting to their initial values whenever the start or stop happens. BsWM can also trigger transmission of an IPDU. So whenever you want to trigger a IPDU based on a different condition check, the input conditions can be any of the mode changes or any of the indications coming. So in that case, if there is a possibility you want to perform the triggering the transmission of an IPDU from BsWM, it is still possible. So generally, the typical use case that I can think of using the BsWM to handle these things to reduce the overall CPU load or the processing times. So these are all we can configure event-based mechanisms here in the BsWM to control or to handle the modes of different COM supported functionalities, like start and stopping of the IPDU groups and all those things. So these are the different services that COM provides to BsWM, or the user is enabled to configure different functionalities from BsWM to COM. Next comes the important module, the PDR. So PDR, what we can do using BsWM? BsWM can enable or disable routing groups of IPDUs in the PDU router. So when we have discussed about PDR, we have talked about the groups of IPDUs. We can configure the groups of IPDUs, and then this routing can be either stopped or enabled or disabled in the PDR module by configuring a BsWM rule. So the list goes on, we will see. Next thing is the CAN-SM. So what are the CAN-SM related functionalities that we can configure in BsWM? So the CAN-SM, the mode switch indications originating from the CAN-SM go through the BsWM for further propagation to application components. Same applicable for Ethernet, of course. All the state managers, it will have that same thing. Like whenever the state of this respective channel is changing from one state to another state, an indication can be given or can be configured in the BsWM to give the information to the application modules, and accordingly the application modules can take their respective actions. So, and in case of LIN-SM, so we have spoken this CAN-SM and Ethernet, both the things will be having the indications. Whereas in case of LIN-SM, BsWM coordinates switching of LIN schedule tables in the LIN-SM with starting and stopping of the corresponding IPD groups in COM. Mode switch indications originating from the LIN-SM go through the BsWM. Okay. So this mode switch indication is the same as the whatever we have discussed in CAN-SM and the Ethernet SM case, but the extra functionality is that whenever we want to have the configuration of switching of the LIN schedule tables, switching from one LIN schedule table to a different LIN schedule table, this is done using the BsWM module. In any of your project, when you want to configure switching of LIN schedule tables, you have to perform the action using we'll have the LIN schedule mode indication ports or mode request ports, and using these ports, the BsWM will receive the request from the application modules, and the same request is passed on to the LIN schedule manager, okay, the LIN state SM, okay, LIN-SM. So that will be given, and then the LIN-SM will sets the respective schedule into action, and then this is done by using the enabling or disabling the respective the starting and stopping of the respective IPDU groups. So inside the COM module. The next comes is the LIN-TP. LIN-TP is for the diagnostics over LIN. The LIN transfer protocol. So this is part of the LIN-IF implementation. If you can see in any project, so the LIN-TP will be requesting to switch into diagnostic mode from the normal communication mode, and then the respective LIN schedule table. Diagnostics also will have a LIN schedule table in case of LIN. So using the BsWM, we can switch to this diagnostic schedule table by giving the request. Again, the request will be coming from DCM module, and then to the then it will be given to LIN-IF, and then the LIN-IF the DCM module will be giving the indication to BsWM, and then BsWM will switch from the normal schedule table to the TP schedule table, the diagnostic schedule tables. Next thing is the DCM. The DCM perform mode request to the BsWM based on the diagnostic request. So we can also configure diagnostic service implementation using BsWM, where the request coming from DCM to the BsWM, then the BsWM will be able to request for the different switching of different modes. DCM can request disable normal communication. So DCM can request the normal communication, the communication manager. The request can happen via the BsWM module. During this mode, BsWM will turn off the corresponding IPD groups and NMPDs. So whenever the request comes from the DCM to disable a normal communication, so what BsWM will do, it will switch off all the turn off all the corresponding the IPD groups and the NMPDs, whatever we have on that respective communication channel. Okay, so the last in today's list that we are going to look at, because there are other services which are again provided for service discovery if you are using Ethernet and all. Okay, we are not going to, we are actually discussing on the very basic things that we'll be typically using in any project. So next important that comes into picture is the NVM module. So the NVM module reports state of its blocks to the BsWM via integration code registered as NVM callback. So we have the NVM callbacks that can be configured in NVM, and using these NVM callbacks, the module related block status will be given, and then based on this block status, again we can perform different actions. BsWM actions causing the NVM to read and write all blocks during startup and shutdown. So even this the read all during the startup and the write all during the shutdown, this can be performed using the BsWM support. The NM interface, so the last one. So how does NM will be supporting the BsWM, or how NM will be working along with BsWM. BsWM will use the NM enable communication and NM disable communication to control the NM communication based on the current mode. So based on whether the indications that it will be getting from NM, that is enable communication or disable communication, BsW will be accordingly perform the actions on the communications. So let's say a small example. In disable normal communication mode, the BsWM needs to disable NM communication on the corresponding NM channel. The NM uses BsWM NM car wake up indication to indicate a car wake up. So basically, if you take and disable normal communication mode, what BsWM will do, it will disable the NM communication in the respective NM channel. So whatever is the disable normal communication came, the request came. So on the respective NM channel, it will disable all the communication related to NM. And whenever there is a wake up condition coming into picture, then it can actually again uses this NM car wake up indication function. So the function will be called and then it will indicate the car wake up information to NM. Okay, so now if you see how in any typical project, how your BSW module will look like. So if you look at the BSW module container inside your project, it will mainly contain different sections like communication control, ECU state handling, initialization, and then we have miscellaneous, like whatever is not covered in these three will be coming under the part of miscellaneous. So we have seen like, okay, now the BSWM in combination with different BSW modules, how it is able to provide various different services to the users. So the user is having the freedom to configure different rules, and the checks are performed and different actions can be performed, and these actions are nothing but the predefined services that are made available by different BSW modules, including the RTE, to enable or disable to perform certain actions on a condition check basis. Okay, so now we have seen those. So now how they want to organize them. So basically, if you look at the organization, first thing is the communication control. So here you will be seeing the communication control related rules. And whenever I say rules, obviously there will be actions and action list mode. For example, we'll have the logical expressions, and we'll have also the mode related information coming from the mode request ports and mode notification ports and mode switch ports. So different inputs will be there. So basically all the communication handling related rules will be part of this particular section in the BSWM container. And next comes is the ECU state handling. So whenever you want to change from the wake up to start and start to run to post, run post and to shutdown, or again from back from shutdown to wake up, so you can actually configure different rules and then perform different actions based on the ECU mode. And so all those mode related handling related rules are will be coming under the ECU state handling section. And next thing is initialization of the modules. So basically when you see in your any typical project, so you will have to initialize all the BSW modules and the CDD modules. Basically I'm talking about below RTE. So all these modules needs to be initialized, and this initialization is typically done using the BSWM. So where the BSWM, based on the initial mode of our ECU, whenever it is in the initialization sequence, so whenever this happens, whenever the ECM is getting initialized, after that the OS comes into picture, the BSWM will be calling this initialization functions of all the BSW modules, including the CDD modules. So this can be done using the BSWM actions, where inside the actions, the action is like the calling of the init function of the respective BSW module. So this will be done as under the initialization section. And apart from this, like here we talked about communication control. Here we can say like COM, and NM will be coming into picture from the listed modules which we have discussed in the previous slides. When we talk about ECU state handling, yeah, it might be again the ECM which will be coming into picture. And then initialization, yeah, basically it is about initializing all the BSW modules. So this is a typical action done by PSWM. And then rest of all the services, whatever we have discussed for the other modules like PDER and the LIN schedule conditions, those things will be coming under this miscellaneous configurations. So miscellaneous rules configuration. And all of these sections will typically contain rules. And again, for example, when it is about initialization, it is just actions and action lists. So it is just about whenever the init mode is set, then it will call all the initial init related modules. There is no logical expression check and all those things. So basically we'll have actions and action lists here. And for the state handling, again, we are not going to get anything here. So based on the mode, we will be actually handling different actions. So wherever we talk about miscellaneous, like I want to get some indications, mode indications or mode switch related requests, and then mode request R ports and all those things, this will be coming under the miscellaneous section. So we'll be configuring each of these things for each of these sections. We'll see in the next slides. So let's see what are the critical configuration parameters that will be configuring in BsWM. So basically this is all about configuration. So now we understood the theory behind how BsWM works and what are the different services we will be able to configure using BsWM. So now we'll go directly into the configuration. So what do we configure? So the first thing that we'll see in the container configuration is the RTE mode declaration groups. So like I mentioned, we will have to give the indications or details about the different modes that will be used as a condition checks for a logical expression. So those mode declaration groups, which are generally typically the mode related either to give the mode information or to get mode requests from the applications. So there should be some modes to be declared, and then it will be called as mode declaration groups in RTE. And this will be whenever we configure this mode declaration group, they will be available in the BsWM software component. In the application layer, we'll have the BsWM SWCD, the software component description. So that will contain these mode declaration groups. When we talk about the RT mode declaration groups, you will have also the user types and all those things that will automatically be coming into picture. So for this handling of this mode switch interfaces and to support mode indications, so we will be configuring the RTE mode declaration groups. This is typically for the uses in the RTE layer. So without this information, it is not possible to sync between the application layer requests and the BSW, because each should understand what the other guy is requesting. So this mode declaration group is the common language that they speak. So each mode declaration will be having different modes that will be configured as a part of mode declaration group, and each mode will be having its own identity, and this whenever this identity is received from the respective mode, I mean the respective port, the mode switch port or the mode request port. So then the BsWM will be able to validate, and then accordingly it can take an action. So the first thing that we configure is all the modes that we want to make use in the RTE layer for the BsWM configuration. So this will be the first thing that we'll be configuring. So typically this will have all the implementation types and then computation methods, all that we see in the RTE application things. So for understanding a typical user defined data types, so you will see all those things for this mode declaration groups. And the next important thing is that we have seen the arbitration and the mode control. So like we have seen the arbitration is all about the rules and then the logical expression checks, and then the execution of this to switch into different modes and all will be coming under mode control. So we will see first arbitration. First thing that comes into picture is the logical expression configuration. So this logical expression, what we'll be configuring, we'll be giving a logical name to each logical expression. For example, I can take an example of for a logical expression, I can say like enable the communication on CAN channel 1. So CAN channel 1 enable TX and RX communication. That can be a logical name. And then inside that, the logical operator. So like we have discussed, the logical expressions will be like list of checks, condition checks, and then are grouped or checked against each other using the logical operators. So we will have the list of checks coming into picture using the logical operators and then here when we talk about a logical expression, so when we are talking about logical expression, it is basically checking the condition against a pre-configured condition. So basically we'll need to give a reference to the mode conditions. What is the mode condition that we are talking about here? So the mode condition, the next thing that we are going to see here, what is this mode condition is all about. So this logical expression will have a reference to a mode condition. And what do we mean by mode condition is that, again, the configuration of mode condition, we will have again a logical name, and here we thought about the CAN SM. So in this case, the condition modes available from BSW modules, RT modes declared, or the condition type. So basically here we will say, I can say in this case when we talk about communication, I can say the CAN SM channel state will be the mode that I will be checking in this particular logical expression. So the condition will be for me the CAN SM channel states. If it is for example, if it is for a LIN schedule manager. So I will have the schedule table related information that will be acting as a condition mode. So what then in that case, what BsWM will do? BsWM will have a lint schedule table. From that, a schedule will be requested. So the BsWM will be checking the requested schedule against the list of schedules already given as a condition modes here. And then the condition type. So here we have two possibilities. We can do the condition check as like equal or not equal. So when the received request mode is equal to my configured mode, this can be one type of check. Or when the request received mode is not equal to the pre-configured mode, again you can perform the true and false operations for this logical expression. Okay, so the logical expression, we have configured the name, the logical operator, we have combined the checks using the logical operators, and then we have also given a reference to the mode condition against which we want to check. And then mode condition, we have seen what and all will be configuring. Then next important thing that we need to configure is the mode request port. So when we talk about mode requests or indications, always we understand that we will need some ports to be configured to receive these requests or given indications. Okay, so let's see what do we configure as a part of the mode request port. So obviously the first thing is the logical name, and then the request processing, like we discussed in the, I think, very beginning slides. So there is the request processing. How do we handle the request processing? So we have discussed there are three types. So you have to configure here to any one of these parameters. It can be immediate, it can be forced immediate, or it can be deferred. So the request processing will be configuring it here. And then the mode init value. So whenever during the very initialization of your ECU, so the BsWM want to execute your check the valid conditions in this inside this mode request port. So what should be the init mode value that it has to consider for the very first time, and the next time onwards it can be based on the request coming or indication coming, but for the very first time you should have some init value configured. And the next thing is the mode request source. So the mode request source, I think like we have discussed, these are all predefined, the source of mode information from the BSW mode. For example, so what will be the source of your mode request? So it can be a CAN-SM related indication, or it can be indication coming from NVM that the NVM job is done, or it can be a TX confirmation coming from the PDR. So there should be some there should be some indication or the source for the request for this respective mode. So you will also be configuring what is the source of your mode request. So basically these are the typical parameters that you will be configuring for mode request ports. And then finally the rules. So when we say about rules, like I talked, okay, we'll give a logical name, but then it is obviously a reference to a logical expression. So rule is nothing but checking of a logical expression. So we will give a reference to the logical expression which we have configured above, and then the rules false action list and the rule init state and the rule true action list. So every rule will have init state, either it will be set to false or it will be set to true. And whenever we talked about, like, whether you want to execute based on a change from the previous state, that is the condition based or the other one, okay, the triggered based. So there, this will be the main thing that will be having a peculiar role, the rule init state. So only when the state changes from an init state to a different state, so we will be checking this, or we will be performing the action list. So again, typically, like with the logical expression, every logical expression will have a result of either a true or false. So in the case of true, we will have to mention an action list, and in case of, again, false is optional. So if the logical expression fails, either you can give an action list and the action list will be executed, or if you can also leave it blank, so nothing will be done during this case. So now these are all the different arbitration related configurations. So here we have seen logical expressions, mode conditions, mode request ports, and the rules. So next comes is the data type mapping set. So like, say, each and every mode that we are configuring, so we should be mapped to a data type mapping set. So we will be giving a data type mapping set reference for the BsWM software component description. So this is just giving a reference so to which mapping set all these the modes that will be handled by BsWM are mapped. So once this is done, then we will see the next important thing, that is the mode control. We have seen the mode arbitration. So now the rules are executed, execution, the logical expressions are verified now, and then either we have a true action list to be executed or a false action list to be executed. So we have to define those action lists. So I'll go in sequence. So before going to the action list, first we should configure the actions. So again, coming to the action, we will have a name. And then, like I mentioned, the actions are all predefined and we will be configuring under the parameter called BsWM available actions. So all the predefined actions will be listed out here. And generally in any stack, you have to just, right click and then choose from the available options, or from a drop down menu, you have to choose the available action. And the example can be common allow communication. So these are the different actions that will be supported. Like we have seen the list of the services that are provided by different BSW modules, all those services which are enabled for your project. So basically, what do I mean by enabled? Enabled means in the general configuration of your BSWM. So you will have the option to enable or disable the BSWM and the respective BSW module related interactions. So only on need basis you can enable these things, so that the BSWM will be generating the respective services to make it available to the application layer or not, based on this enabling and disabling option in the general configuration. So whatever all the enabled options, so based on the available enabled options, for example, if I enable COM, so the COM will have 3 or 4 kinds of actions that are predefined. So enable, disable communication, enable a particular respective PDU group, all those things. So these are the different actions that, for example, list of 5 actions that will be enabled only when the COM BSWM configuration is enabled. Okay. So similarly, for example, for LIN diagnostics, so BSWM LIN TP configuration should be checked to true here in the general configuration. Then only we'll be able to configure the communication between the DCM and the BSWM to enable or disable or switch to a respective diagnostic schedule table. So all the based on the configured configurations done in the general configuration for the respective BSW module, those available actions will be listed out here. So here it will be like choosing from the existing options. So either it's a drop down or right click and then select whatever is the options that are available. So we will be selecting the respective action, and the typical is again something like a user callout function. So wherever you can also, you want to call a function not from the BSW services, you want to have your own implementation of a BSW related, apart from the BSW related services provided. So if you want to configure a callout, so you can also configure for a user callout function in the available actions. This is one of the available action from where you can call your respective callout function. And the next important thing that you configure is the RTE mode request port. So again, when we talked about the request coming from the RTE, so we'll also need to give the RTE mode request port related information. Mode request port for BSWM to send a mode request to a software component, that is the mode manager. So when example is like we are configuring a application module in the application layer, we are configuring our own mode manager related dummy or wrapper functionalities. So in that case, BSWM will need to request this module for a different mode request. Okay, so in that case, BSWM is going to request the application module. In such cases, the RTE mode request port needs to be configured. And then we'll also have the switch ports. So basically, these are the mode switch ports. So we'll give a name for this mode switch port, and that it will contain mode switch interface references. So whenever we configure this BSWM software component description will be configured in the RTE layer or the application layer to support the services in the BSWM. There we'll have this list of mode switch interface related configurations. These are typically used for RTE switch actions and the schedule manager switch actions. So we'll be configuring this switch ports as well as a part of the mode control. So mode control, basically we have seen two things, action list and the actions. And then we have the RTE mode request. So there are two, when we're talking about the mode control, two more things that comes into picture is the RTE mode request ports and the switch related switch port request. So these are typically the mode control related configurations that we will be doing. So, and in general, so what will be coming as general configuration for the BSWM is the optimal configuration of enabling disabling for various services. That is what we have talked. So based on whatever the modules or related services you want to use in our project, you can enable or disable those respective modules here in this general configuration. And then anyway, obviously we mentioned that the main function periodicity. we'll have to configure, and at what time the BSW main function will be executed. And then you will have some user configuration related call out functions, and then user call out files, and all those informations will be part of the general configuration. So basically, as we understand here, it is BSWM configuration. As you can see, it is very simple. You can see just very less parameters, and then the main thing that we have to understand here is that it is all about how we carefully design our checks rules, and then how do we optimize them and then to perform the actions in a sequence. Okay, so basically we are done with the configurations and then the very basic understanding about the BSWM. So typically, if you understand, the main thing that you should remember when we talk about BSWM is rules. The rules contains verification of logical expressions. Logical expression contains verification against mode, so which means we need some mode conditions. And whenever the logical expressions need to be combined, it will be combined using logical operators like AND, OR, and NAND, NOR, something like that. And then when this logical expression check either passes or fails, there are two possible options, either true or false. And based on this logical expression result, check result, we will be able to execute action list, and action list can be executed again in different methods that we have seen. And this action list again is combination of lists in a sequence. So this list, what we have to understand is that there will be indexes, I think, which I would have missed it here. Okay, so when we talk about an action list, so we will have the name, and then when we talk about the action list, so we can also actually configure abort on failure. So when you are executing an action list, let's assume there is a failure. So what BSWM has to do? Will it need to wait, or it has to come out, or all those things? So then we can configure or enable this abort on failure. So whenever there is a action list execution failure happens, it can abort and it can continue with the next thing. And the other thing is the index. Okay, so the main other thing is the index for an action list. So inside an action list, you will have a list of actions. So each action should be having a action list related index number, and then why it is used or how it is used. So based on this index value only, it will be executed. The list of actions will be executed in the respective sequence. So if you want to change the order, you have to just simply to change this index. So accordingly, the BSWM, whenever it is performing the action list or executing the action list, it will execute the list in the respective manner as per this index value. Okay, and then you can also give a action list reference. Obviously, will be giving the action list to the respect to the action, and then report failure to them. So there is also an option to for the failure reporting. Whenever there is an failure happens in the execution, you can give an you can map that to a dump event which is already configured, and this dump event will be set whenever there is a failure happening in the action list execution. Okay, this is one other important thing. So, and then again, we will also have the priority for each and every action list. So the whenever there are multiple requests coming, so they will be set into queue and based on the priority. So higher the value, higher is the priority. So you can also set this priority value so that whatever is the more important thing that can be executed with the priority in whenever you are executing in a queue or in the normal execution. So I think typically I have covered almost all of the things. So I think this should give you a complete understanding. We have covered almost how it is will be generally executing. So basically, if you see from your general code in your project code, you will have the BSW main functions where it will be arbitrating for all the rules. And whenever they are met, you will have the each and every action will have, or action list will have a separate function, and that function will be called whenever the condition is met or the logical expression is true or false accordingly the respective action list. And inside the action list, you will see then, like I mentioned, action list can again contain an action, and the action is to call again a different action list. All these are all nested action lists are possible. So inside that, you will have the list of actions. Sometimes it will be call out functions, or it can be a function call to or a what we call a mode request to a BSW module, or a mode indication to a upper layer to the application layers. So these are the different things that you will see in your generated code. So BSWM is very simple. Typically, from my experience, you will start to use it right from the initialization of your ECU, because all the BSW modules, the init functions of the BSW modules will be called using the initialization feature supported by the BsWM. So where you will have all the init related callouts, and in the order, like I mentioned, wherever you want a respective module to be initialized before the initialization of the next module, so you will handle it using the index values in an action list for the action items. Okay, so right from the initialization, BSW will be having their own thing, and then whenever the request, the many mode requests coming from application layer to the BSW layers, the mode request will be handled again using the BSW modules, the BsWM module. And then whenever there are more changes happening, the notifications always again will be handled using the BsWM. So these are the typical use cases that you will see in every automotive project. And basically, I think now I am done. If we have, did I miss something? So if anybody feels that there are some things which are missed, we can actually discuss. And coming to the references part, all this presentation content is taken from the BSW mode manager document, or the technical reference, SWS reference from the AUTOSAR website. And like we always discuss in everything, so basically when we want to learn a module, we should go through this SRS and SWS. The SRS contains what is required to do. This basically the requirements, and SWS is how we do that. So basically, if you see, the SWS is what we are referring here. So we are actually looking at how we can achieve different services. That's what we have seen in this complete session. Yeah, please stay connected with us using our website. There are forums and groups related contents where the users can actually interact with us, or users can interact with each other to help each other in our website. So you can go through the website, and then we have some Facebook pages to interact, and then LinkedIn and Instagram, Twitter, and all these sessions are recorded and available in YouTube for your future references, if in case. With this, I will leave the forum open for any question and answers.
Oh,
Yes,
I
please.
have a question here.
Yeah,
So you said the BSW model will initialize the during the sort of initializing the BSW models.
correct.
So in our project, actually you meant about the driver initialization, or
Yes,
um,
all the, for
how is
example,
it?
when I say about BSW modules, it is also including the MCAL modules.
Basically, these MCAL model initializations happen at the level of UCM, right? So how does this? I mean, how does this interaction between BSWM
So
and the
when you look at the
ECU?
basic initialization of your software, so you will have, for example, from the your controller level, so you will have a main function that will be called, and inside this main function, you will be having the init memory and the init functionalities, and then
Yeah.
we'll be starting with the UCM initialization. Correct, right?
Yes.
Okay, and inside the ECM initialization, you will have driver related, them called driver related. You will have something, if I just take from a general stack implementations, you will have driver init 0, where you will be again initializing the memories for these driver modules. And then you will be in the driver init 1, you will be having the driver related initialization, correct?
Yes.
Okay, so when we talk about this, okay, so we will have different modules which will be initialized. But for some of the modules, so I will tell you the typical use case and where this will be. For example, inside your initialization, okay, you want some of the features which are supported by OS. That is assume. Okay, for
Yeah.
example, if you want to make use of the OS timer related functionalities, so during this ECM initialization, the OS is still not into the run mode, correct?
Yes.
Okay, so but you want to make use of some of the features uh, which are supported by the OS, and then those features will be available only after the OS is entering into the run mode. Correct, right? Okay.
Yes. Yes.
So now, in the very beginning of this OS entering into a run mode, okay, we call it as the init mode. Further, for the OS, correct? Okay. So in the, for example, when we take from the RTs initialization generally, okay, where the scheduler will be starting. So in this case, we want to perform the initialization of these modules based on the services also available from the OS in this case. So in such case, we will not be initializing these modules in the driver init 1 or driver init 0. Okay, we will be doing it immediately after the OS run into OS is coming into the run mode, and but at the initial level of this mode. So in some cases, if you look at your general projects, all the drivers which do not have any dependencies on the OS, they will be done in the driver init 1. Okay, and all the BSW modules. So I can think of, for example, the communication like CAN, Ethernet, FlexRave, or whatever it is. All these init functions, okay, will be called using this BSWM initialization sequence. And again, it is not a must and rule, okay, but it is again depending upon how do you architecture your OS, or how do you architecture your project.
Okay, actually, I have gone through two projects. In both the projects, they are having a initialization something like driver init 1, driver init 2, and driver init 3. So
Correct.
as you said, driver init 1, they are doing the basic drivers like a timer initialization and all. In the driver init 2, they are doing the communication driver
Correct.
initializations
Correct.
the way.
Yes.
But
So in
might
your
be
projects, you haven't seen the BSWM usage for the
yes,
initialization, right?
yeah,
Yeah. Okay. So typically,
might be
I have different use cases and different experiences.
yes.
Gosh, so basically, like, so for example, when you configure, let us assume you are configuring a safety compliant thing. So there you might have to provide initialization in a safe manner.
Mm.
Okay.
Okay.
And when it comes to the when I talk about safety, so you will have something like, the memory partitioning and protection, correct, right? Okay.
Yes.
And you want this particular module, which is a safe module, to be initialized in the safe context, correct?
Okay.
Okay, so in
Mm.
such cases, this overall protection provided by the OS will come into picture only after the OS comes into picture, correct?
Yes.
So in such cases, you will need to initialize these modules from a safe context after the OS comes into run mode, or the OS memory
Yes.
protection starts or comes into picture. In such cases, typically we will change it from this driver init 1 to after OS initialization. So these are all again different use cases. So that's what. So all these BSWM related services, they are not like must to use.
Okay.
Okay, so it is these are the different provisions that are provided by AUTOSAR for the different mode management things. So all these functions, whatever that we are configuring in BSWM, like we have seen the typical code, it is condition checks, correct, right?
Yes.
If else, if else, if else. Okay, so this can be executed in your own any of your typical CDD module itself. You need not use BSWM.
Okay.
But BSWM by default, it has a it is providing a standardized way of handling it. And like I mentioned, in the general configuration for the BSWM, you can always enable and disable any of these functionalities.
Okay.
Okay, so
So
again, I don't know which I mean which stacks you are using, and each stack has their own preferred ways of handling the things, because some stacks, they would have developed BSWM to a very advanced level that okay, they will be able to monitor different things in a what we call in a decent manner using BSWM. But in some stacks, okay, if they don't have they don't really rely on BSWM, they might not use the BSWM completely at all. Okay, but
okay.
whereas, for example, if you are having any kind of mode related request coming and all those things, okay, again, my experience is mostly it is done using the BSWM. You can tell me, or you can let me know if you have a different observations.
Mm, no, I have not got experience in this
No
kind of
problem.
BSW
No
initialization. So
problem.
that's
Okay.
why I
Yeah.
just want to.
Understood. Yeah. Yeah. Thanks, Prakash. I think now you got it right. So it is again
Yeah.
based on your project related requirements. So if you want to initialize using the modes, ECU modes and all those things, then you can actually rely on BSWM, so that you need not continuously poll for this data and all this. That will be done by using the BSWM.
Okay.
So ECM will give
So
indication to indication to BSWM, and BSWM, the moment it gets this condition check pass, it will start with the initialization functions.
okay. So the safe initializations, maybe for an example, I'm saying the safe initialization will be done at the BSWM level, and then only it will start executing the ECM initialization.
Exactly. So now if you see the ECM initialization in the beginning, so ECM initialization will not have OS into picture. So leaving the ECM
Yes.
initialization, you will have the start OS, correct, right?
Yeah. Yeah.
Okay. So when you want to make use of OS enabled services, you cannot, perform these actions before the OS starts. Okay. None
Yes.
of the functionalities that we get from the OS will be available during the ECM init mode.
Yeah.
Okay, in such cases, okay, again you can perform, you can have a handwritten code that after the OS starts coming into picture, so you can actually make use of this, or the ECM, the BSWM will provide the service where whenever we are entering into this, the action list will be executed, and there you will be calling all of your, you will be listing each action as a calling of your respective functions.
Okay.
It's again because if I take my experience, beginning of the project we have different initialization sequence. But as we entered into this safety requirements and all, we have actually changed these initialization sequences
Okay.
based on the safety partitions and all those things.
Okay.
Yeah. Any other questions?
Yes, I have a question. What kind of interface we use software component to talk with BswM?
So, for example, you are talking about application component, right?
Yes, yes. What kind of interface we use if you want to talk with
We will
BswM?
have the mode switch interfaces or mode request ports. So basically, typically
Uh,
they are mode switch interfaces. So let me share.
so that is not sender receiver
No,
or
no,
the
no,
client
no.
server interface, right? That is
No,
not
it's a mode switch interface. I can show you just a moment. So
okay.
share my screen. Typically, if you want to understand, so it is slightly available from the BSWM. So I'm what you're able to see in the BSW mode manager SWS document, right?
Yes, yes, yes.
Okay. So if you look at the how the applications will be interacting, so there is a section here in the bottom where I can show you. So in the interest of time, so this will be. So these are the BSW interfaces. So here in this section, you will be able to see like, okay, the application mode request interface. So it will be mode request port. So there is actually one diagrammatic representation. That's what I'm looking for, so that it will be directly easily understandable. So it's a mode switch interface. So in your typical representation, you will have a interface with 3 dots, if you remember.
So that means this is a standardized AUTOSAR interface, you mean to say?
Correct.
Because
So this
because I don't
standardized
think we
this So standardized interface,
yeah.
for example, when you enable certain functionality in your BSWM, like we discussed, okay, in the BSW,
Mhm.
you'll have a software component description that will be generated. So if you go to your RT configuration tools, for example, if I have to say vector as an example, you will have DaVinci developer. And if I talk about Mentor stack, you will have VSA, VSB, right? So if you take VSA, so there you will have the BSWM software component description. So that will be providing ports
Mhm.
in the RTE layer to the RTE layer. Okay. And that
Okay.
the similar port needs to be configured in your application module also to make use of the service.
Okay.
Example, if you want to request, so you are requesting. So the BSWM will be the guy who will be receiving this request, correct, right? So
Okay.
so what it will have an R port. Okay.
Yes.
The service provider, then it will have a provider port. Okay. So similarly on
Yes.
the application side, you should have the same port of the same type. Okay. And that type, the port type will be the standard port type generated from the BSWM SWCD. Why?
Okay.
Yeah, it's a standard interface, so there is no doubt in that.
Okay. Okay.
Here it should be there. More processing. You can go through this document.
So these are not sender receiver type, or it's a special type of port.
No, it's a mode switch type. So mode request port, or so like, see, I have given
Okay.
presentation I have showed you, right? Like there are this mode notification ports and mode request.
Okay.
Are the two types of ports that will be supported.
Okay. Okay.
Okay, so you will have the corresponding request interface, and then in your application module. Okay, so here I think this is where it is mentioned in the context of software components, two interfaces are defined. The app mode request interface, this is of type sender receiver. Okay, and where the software component is the sender, and the app mode interface of mode switch type, where the software component can have P ports and R ports depending upon the usage. So these are the two types of ports that are supported for the usage or the handling of the modes with respect to BsWM from the software component side.
And this is sender receiver type of interface you mean to say, or they have written, right? This
Yes,
is of sender receiver type.
no, it's sender receiver type only. The type is sender receiver.
Okay. Okay.
Okay, so here if you can see, this is request and mode interface. Okay, and then again for receiving back the notification, you have the mode notification ports. So here I'm
Okay.
the mode switch ports.
Mm-hmm. Okay.
Okay, so whenever you want to request, it will request for this mode request port or mode switch port, and then accordingly it will get the notification using the mode notification port.
Okay.
Below is the diagram you are.
Okay, so if you can see, the mode switch R port will be generally named as a mode notification port.
Okay.
Okay, in the mode switch, you can have a R port and provider port and receiver port. So whenever you are using the mode switch for an R port, typically we'll call it as the mode notification port. Okay, so
Okay.
for this diagram, sorry. You can see now.
Yeah.
So this is the app mode request interface. So the mode request, you can see here there is a provider port on the application mode manager. So this is an application module. That is simply an application module, but we are actually it as a mode manager where the modes will be handled. For example, if you want it as a communication manager, enable the full communication or put it to no communication. Those requests can be made from this application mode manager, and then BsWM will receive this, and then accordingly it will execute. We are given indication to common, let's say. Okay. So similarly, the mode switch port, you can see here it is again a mode switch port, but here it is an R port, correct, right?
Okay.
So to avoid confusion about the mode switch ports, the R port mode switch port will be called as mode notification port.
Okay.
Okay. So it's a notification that change. Got it? So it can be given to multiple applications. That's what they have tried. They're trying to put it in this picture.
And I just try to understand the interface, whatever they mentioned here, app mode request interface. So is this the sender receiver interface?
Yeah, it's a sender receiver interface type only. Okay, of type this mode switch and mode request.
Okay.
Yeah. Okay, so whenever you're configuring an application module, you have to just configure it as sender receiver type. On the type, that will be the type of that interface will be mentioning, right? There we will be using the BsWM standardized interfaces as a type reference.
Okay. Okay, thank you.
Yeah, clear. Yeah, you can refer to this page. So this is actually, they have given a lot of very good explanation here. So I think it's page number 42. Any further questions? If there are no further questions, we can wind up the session, but I think now you people are good enough. So like I always say, please go through these SWS documents. So everything is there inside these SWS documents, and then you please choose whatever that is you are interested to know. immediately perform. So obviously we'll also have your stack supply technical references, which will be little bit more easier in reading, and then they are directly about the configurations. So please go through this, and BsWM has, it has advantages and disadvantages. So like it is again based on your project requirements and how you design your architecture. So again you have to take it. So, and again, each and every configuration inside this BsWM, we have to always need to ensure that this should not overload or this should not cause any, for example, when I talk about action lists. So when you are configuring the action list, so the sequence need to be done very carefully. Similarly, the action list processing, for example, when I talk about action list processing, so we talked about immediate processing, and then we talked about doing it in the next way. So again, based on your typical timing requirements, if you can wait until next BSWM main function cycle, you can configure that as per that, or otherwise, if you want that to be immediately processed, you can do that. And also try to ensure that when you are talking about immediate mode and forced immediate mode, so when it's about like it will stop the previous execution, so you have to be really careful. So what will happen if you stop something in between? So will it cause any problem to your system? So all these things you'll need to consider during your architecture design, and accordingly you can have to make use of the efficient use of the BsWM provided actions. Got it? So there are different, you can also configure using callout functions. So whenever you need not always, so there are, for the same requirement, you can actually implement using multiple types by different services provided by the BsWM. I think with this it's clear. So I will try to close the session for today. Thank you so much for participation.
Are there any videos or documents on tool usage, like how to configure them, configure the BSW manager?
I really doubt if there are, because the tools are all licensed. Okay, so it's
Yes, yes, yeah.
they might not be, because even the tool supplier, the stack suppliers, they will be conducting a lot of paid trainings. So I am
Okay.
really sure if somebody has put something online, as a part of paid trainings, they might be able to show you on the tool. Okay, but honestly speaking,
Okay.
when
Yeah.
it comes to BsWM, it is that the configuration is very simple. Okay, because
Okay.
told it is very if and else configuration. So if you start from the logical expression, so where you understand this, okay, it's very simple. And and most of the stacks that I have worked, the BsWM configuration is straightforward. So there is nothing much. And wherever you are having some issues, we have these technical references and the SWS documents to support us. Only thing is we need to spend some time. So there is no tool dependency, as I can say, for at least for BsWM. Okay, and it's very simple. So hardly, if you want to configure one rule and all, hardly you might, if you are very clear on what are the conditions you want to configure, what are the logical expressions you want to configure, and what are the actions you want to perform, it is hardly like it will take you 10 minutes, not more than that. It is all about you understand the theory more important. The tool configuration is very simple for BsWM.
Okay. Thank you.
Thank you. Any further questions?
Hello.
Yeah, please.
Yeah, suddenly some basic question flying on my mind.
Yeah, please.
For example, the immediate mode, the action list is progress,
Correct.
and immediately we are getting force immediate. So
Yeah.
what will happen? The partially, for example, the action list is completed. Then we are getting a request from BsWM or SWM force immediate.
Correct.
So in that case, what will happen?
What will happen? So yeah. See, forced immediate is like we have discussed. Forced immediate will interrupt two things. The one which is being executed as immediate, okay, and then also which is being executed as a default mode. That is like in the normal BSW main function. Okay, so either of these two things happening, and in this case, then suddenly there is a forced immediate coming into picture. Okay, so what the BSWM will put them into queue. So immediate functionality will support queuing mechanism. Forced immediate, there is no queuing mechanism. Okay, so whenever there is a immediate action list is executed, being executed, and at that time there is a forced immediate. What BsWM will do, BsWM will pause the execution of the immediate action list. It will first attend the forced immediate, and then once it is completed, then it will actually resume with the immediate action list execution. Same is the case. So for example, during this again a new immediate, when the forced immediate is being executed, there is a new immediate request came. So what will happen, this new immediate request will go and sit in the queue. Okay, so the forced immediate is the highest priority. Whatever it is doing, BsWM will stop all those things and it will attend to this forced immediate. Okay, so that's the reason we are saying we cannot have more number of action list configured as forced immediate, unless and until, for example, your stack has the ability to what we call handle multiple forced immediate requests. So it is again your stack suppliers related constraint. So they will mention you if forced immediate is first of all supported or not. I have seen certain stacks where forced immediate is not available. I've seen only immediate and deferred, and certain stacks I have seen, advanced stacks or the latest stacks, so I have seen they are supporting this force immediate. But again, there are a lot of pre-restrictions, or they will give recommendations like please use it with very absolute discretion, okay, so that it should not interrupt the general functionality. So let us assume that the forced immediate is coming very frequently in your system, then it will obstruct the other functionalities of your system, correct, right?
Yes.
Yeah, so we have to be a little bit careful. But to answer your question, what will happen when the forced immediate comes? When forced immediate comes, BsWM will stop all of its cyclic checks or the sequential checks. So or the cyclic sequential implementation of all the other action lists, and it will attend to this action list after this completion of this forced immediate action list only. Then it will continue with the rest of the immediate action lists or deferred action lists. Clear?
Thank you.
Yeah. Thanks, Karthikeyan.
Yeah.
Anything else?
Fine.
Cool. Then if you are all okay, yeah, then we can call it for a day. And thank you for joining us. So we will try to come up with many such sessions in the coming future. So where we are trying to start with the basics, and then as we complete with the basics, we will also try to go into specific topics inside each module, inside each functionality. So if there is anything that will be of interest, so we will go into each of those specific topics in the coming weeks. Thank you so much for joining. Please share the information about our sessions to your friends and colleagues, and also please encourage them to watch our videos on our YouTube channel and subscribe them. Thank you so much. With this, have a nice day. Thank you. Bye-bye.
Thank you. Bye.
Bye bye.
Have a nice day.
Have a nice day.